Welcome to your brain. This is where reality is born. Every second, over 11 million bits of information flood in from your senses. But here's the thing. You don't experience all of it. In fact, you barely experience any of it. Your brain is a master of editing, a sculptor of perception. It's not just observing the world, it's actively constructing it. So let's take a journey inside the mind and see how your brain creates the reality you experience every day. Your brain doesn't see the world as it is, it sees the world as it needs to be. Think about this. You're sitting here right now, and yet you're not actually seeing everything around you. In fact, you're missing a lot. There's a spot in the center of your vision that's completely blind. It's called the blind spot, and it's where the optic nerve connects to the retina. Every time you look at something, your brain fills in that blind spot with what it thinks you're seeing. It's like a game of hide and seek, and your brain is always the seeker. Cut to a close-up of a person's eye, then a split screen showing the blind spot in one eye and the completed image in the other. Narrator. Now let's talk about attention. You're not paying attention to everything at once. Your brain is like a bouncer at a club, only letting in the most important information. It's why you can drive a car and listen to music at the same time, even though both require full attention. It's also why you don't notice your own nose because your brain is too busy focusing on everything else. Cut to a person driving a car while listening to music, then a close-up of their nose, which they barely notice. Narrator. Your brain is also constantly editing reality and time. When you move your eyes quickly, like when you're reading, your vision shuts down for a split second. It's called a saccade, and it's how your brain gives your eyes a rest. But it also means that during those quick movements, you're not actually seeing anything. Your brain is filling in the gaps, creating a seamless experience of the world. Cut to a person reading a book, their eyes darting quickly from word to word, then a slow-motion shot of their eyes moving. Narrator. Now, let's talk about memories. They're not like a video recording. They're more like a collage, constantly being edited and reconstructed. Every time you remember something, you're not just playing back an exact copy. You're creating a new version. It's why eyewitness testimony can be so unreliable. It's also why you might remember a conversation differently, depending on who you're talking to. Cut to a courtroom scene with a witness testifying, then a montage of different people recalling the same event in different ways. Narrator. Colors don't exist the way you think they do. They're not a property of the objects themselves. They're a perception created by your brain. Different animals see the world differently because of differences in their visual systems. A dog might see a bright red ball as something entirely different from what you see. It's a reminder that reality is not objective. It's subjective, shaped by the brain. Cut to a split screen showing a dog looking at a red ball and a human looking at the same ball, with different color perceptions. Narrator. Your brain is always seeing the past. It takes time to process sensory information. That's why your conscious experience is always slightly delayed. It's like you're always watching a movie with a few seconds of rewind. Your brain is constantly predicting what's going to happen next, creating the seamless experience we call the present. Cut to a person catching a ball, with the ball's trajectory predicted by their brain before it's actually caught. Narrator. Your brain is a prediction machine. It's constantly making educated guesses about what's going to happen next. It's why you can understand speech even when some words are missing. It's why you can read partially misspelled words. It's why you can see optical illusions and still know what's really there. Your brain is not just observing the world. It's actively creating it, one prediction at a time. Cut to a person looking at an optical illusion, with their brain quickly correcting their perception. Narrator. Now, here's the thing about all this editing and reconstructing. Your brain is not trying to deceive you. It's evolved to maximize survival. It's creating the most useful version of reality, not a perfectly accurate one. It's why you don't need to see every single detail of the world to navigate it. It's why you don't need to remember every single thing that happens. It's why you don't need to see every single color in perfect detail. Cut to a montage of different animals in their natural habitats, each experiencing the world differently based on their unique visual systems. Narrator. Your brain is not a window to the world. It's a tool for survival. It's shaped by evolution, by your experiences, by your needs. It's constantly creating a reality that's just right for you. So, the next time you look around, remember this. What you're seeing is not the world as it is. It's the world as your brain has decided it should be. And that's okay. Because in the end, the most important thing is that it works. It keeps you alive, it helps you survive, it lets you experience the world in all its wonder. Final shot, a time lapse of a sunrise with the camera slowly pulling back to reveal the viewer standing on a hill, looking out over a vast landscape. The screen fades to black. Narrator. So, how much of reality do you really experience? Is it all there, or is it just a shadow of what's really out there? The answer might surprise you, but one thing is certain. Your brain is not just observing the world, it's creating it. And that's a journey worth taking. Your brain can invent things that never happened. Right now, a massive biochemical machine inside your skull is editing your reality, inventing memories that never happened, and altering who you think you are. Everything you see, remember, and believe is a tailored construction, a heavily filtered simulation created by a dark, wet organ weighing just 3 pounds. This is the hidden world of the human brain, a complex biological supercomputer that values your survival far more than it values the absolute truth. Most people live under the illusion that memory works like a high-definition video camera, recording events exactly as they unfold and storing them away in neat files to be retrieved later. Science has proven that this is completely false. Your memory is not a recording device, it is a reconstructive storyteller. Every single time you recall a past event, your brain does not pull up an unchanged file. Instead, it rebuilds that memory from scratch, combining fragments of actual facts with your current emotions, recent beliefs, and random environmental cues. This means that every time you remember something, you are changing it. The very act of remembering alters the neural pathways, transforming the original story. Because the brain despises blank spaces and craves narrative cohesion, it will ruthlessly fill in any missing details with convincing lies. If you cannot remember what color shirt someone was wearing during an argument years ago, your brain will seamlessly insert a color that makes sense in the context. And it will do it so smoothly that you will swear you actually saw it. This fragile architecture is how false memories are formed. In the early 1990s, pioneering psychologist Elizabeth Loftus demonstrated just how easily the human mind can be manipulated into adopting entirely fabricated pasts. Through her famous lost in the mall technique, researchers successfully convinced nearly 1/4 of healthy adult participants that they had been lost in a shopping mall as young children, rescued by an elderly stranger and reunited with their parents. The participants did not just agree with the premise, they actively expanded on it. They began describing the stranger's clothing, the overwhelming fear they felt, and the exact tone of their mother's voice when she found them. None of it had ever happened. Their brains had taken a simple suggestion and built an entire, emotionally vivid reality around it. This inherent instability is why eyewitness testimony is notoriously unreliable in courts of law. Jurors often look at a confident witness and assume that confidence equals accuracy. However, cognitive science shows there is almost zero correlation between how certain a witness feels and how accurate their memory actually is. In high-stress situations, such as witnessing a crime, the brain floods the body with adrenaline, narrowing focus to immediate threats like a weapon while completely blurring the surrounding details. Later, when investigators ask leading questions or show photographs of suspects, the brain quietly incorporates this new information into the original memory. By the time the witness takes the stand, they genuinely believe they saw the face of the accused at the crime scene, even if that person was miles away. The Innocence Project has used modern DNA evidence to exonerate hundreds of wrongfully convicted individuals, and in over 70% of those overturned cases, the primary evidence used to convict them was mistaken eyewitness identification. The brain rewrote the past, and an innocent person paid the price. 2. Your brain can change your personality. If rewriting your past sounds unsettling, consider an even deeper layer of this hidden world. Your brain can radically change your personality. We tend to view our core identity, our temperament, our values, and the way we react to the world as a fixed, unchangeable pillar of who we are. The truth is that your personality is a fragile product of physical brain architecture, and it is far more fluid than you realize. The most famous historical demonstration of this occurred in 1848 to a railroad construction foreman named Phineas Gage. While working in Vermont, an accidental explosion propelled a 3-foot-long, 13-pound iron rod clean through his skull. The rod entered below his left cheekbone and exited through the top of his head, destroying a massive portion of his left frontal lobe. Incredibly, Gage survived the initial trauma, woke up within minutes, and was able to speak and walk. Physically, he made a staggering recovery. Psychologically, however, he was entirely gone. Before the accident, Gage was known as a highly responsible, polite, intelligent, and capable leader. After the injury, his personality shifted so violently that his friends famously stated he was no longer Gage. He became erratic, disrespectful, prone to profanity, and completely incapable of planning for the future. The physical destruction of his frontal lobe, the region responsible for emotional regulation and impulse control, instantly erased his former self and created a completely different human being. This radical transformation is not limited to sudden, horrific physical trauma. Neurological disorders and neurodegenerative conditions can quietly dismantle a personality over time. For instance, frontotemporal dementia can slowly degrade the parts of the brain that govern social conduct and empathy. Family members often watch as a lifelong kind, gentle, and deeply empathetic parent gradually transforms into a cold, detached, or socially inappropriate stranger long before their memory begins to fail. The person is physically there, but their personality has been fundamentally rewritten because the neural networks supporting it have eroded. Even without injury or disease, your personality is undergoing a continuous, slow-motion shift due to everyday life experiences, learning, and the natural process of aging. Every habit you form, every major trauma you endure, and every profound realization you experience alters the physical structure of your brain. The brain you have today is not the brain you had a decade ago. As we age, the prefrontal cortex continues to mature well into our 20s, which is why the reckless, thrill-seeking teenager naturally gives way to a more cautious, long-term planner in adulthood. Later in life, changes in neurotransmitter levels and structural connectivity can cause people to become more agreeable, less neurotic, or conversely, more rigid in their ways. Your identity is not a static monument carved in stone. It is a living, breathing tapestry that your brain continuously weaves, modifies, and reinterprets based on the physical state of its neural pathways. 3. Your brain never truly rests. Even when you decide to take a break from this constant reshaping and lie down to rest, your brain refuses to join you. Your brain never truly rests. For decades, scientists assumed that when a person sat quietly doing nothing, or when they drifted off to sleep, the brain simply dialed down its activity into a low-power standby mode. Modern neuroimaging completely shattered this assumption. When you stop focusing on the external world, a massive, interconnected web of brain regions known as the default mode network, DMN, immediately flares to life. The default mode network is essentially the brain's internal workshop. It consumes an immense amount of metabolic energy, often just as much as when you are solving a complex mathematical puzzle. When you are daydreaming, staring out a window, or letting your mind wander, this network is working overtime. It is processing your social relationships, evaluating your past choices, simulating hypothetical future scenarios, and constructing your coherent sense of self. This is where your internal monologue lives. Far from being a state of passivity, quiet moments are when the brain actively builds your narrative identity. When you transition from quiet wakefulness into deep sleep, the internal activity becomes even more intense and specialized. Sleep is not a passive shutdown sequence. It is a highly active, strictly coordinated maintenance shift that is absolutely vital for your survival. One of its primary functions is memory consolidation. Throughout the day, your brain takes in a massive onslaught of sensory data, experiences, and information, storing them temporarily in a structure called the hippocampus. The hippocampus has a limited capacity. During the night, the brain initiates a complex dialogue between the hippocampus and the neocortex. It replays the day's experiences at high speed, deciding what is important enough to keep and what can be safely discarded. It takes the fragile, temporary memories from the day and integrates them into the stable, long-term storage of the cerebral cortex. Without this nightly transfer, you would lose the ability to form permanent memories and learn new concepts. While this consolidation is happening, your brain enters the vivid, bizarre world of dreaming, particularly during rapid eye movement, REM sleep. During this phase, your emotional centers, like the amygdala, become highly active, while the logical prefrontal cortex is largely deactivated. This creates a unique neurological environment where the brain can process intense emotions and anxieties without the constraints of logic. It acts as a form of nocturnal therapy, stripping away the painful emotional sting from difficult experiences so you can wake up the next day with a fresh perspective. Simultaneously, during deep non-REM sleep, a specialized waste clearance system called the glymphatic system opens up. The spaces between brain cells increase by up to 60%, allowing cerebrospinal fluid to rush through the tissue like a biological dishwasher, flushing away metabolic waste products, including toxic proteins associated with Alzheimer's disease. Rest is not a luxury or a state of emptiness. It is the active process that prevents your mind from collapsing. 4. Your brain can fool you into seeing patterns that don't exist. This active nature of the brain is driven by a deep evolutionary mandate to find meaning in the chaos of the environment. Because of this, your brain can easily fool you into seeing patterns that do not exist at all. From an evolutionary standpoint, the human brain is a hyperactive pattern recognition machine. Millions of years ago, on the African savanna, our ancestors lived in a world filled with hidden predators and unpredictable dangers. If an early human heard a rustling in the bushes, they had two choices. They could assume it was just the wind, or they could assume it was a hidden predator. If they assumed it was a predator, and it was just the wind, they made a harmless error, known as a false positive. But if they assumed it was just the wind, and it was actually a saber-toothed cat, they were eliminated from the gene pool. This asymmetry heavily favored the survival of individuals whose brains were hypervigilant, wired to see intent, faces, and meaningful connections everywhere, even in completely random noise. This evolutionary bias has left modern humans with a brain that constantly hallucinates patterns. One of the most common manifestations of this is pareidolia, the psychological phenomenon where the brain visualizes recognizable shapes, particularly human faces, in inanimate objects. This is why you instantly see a smiling face in the front grille of a car, a weeping figure in the knots of a wooden door, or the shape of an animal in a passing cloud. The brain contains a highly specialized area called the fusiform face area, which is entirely dedicated to detecting and processing human faces. Because recognizing faces is critical for human social survival, communication, and danger detection, this area is set to an incredibly low threshold. It would much rather trick you into seeing a face in a burnt piece of toast than miss an actual face hiding in the shadows. This tendency extends far beyond visual illusions into our cognitive processes through a phenomenon called apophenia. Apophenia is the tendency to perceive meaningful connections between completely unrelated things. It is the underlying mechanism behind superstitions, conspiracy theories, and the belief in luck. If a person wears a specific pair of socks and happens to win a game, the brain immediately notes the coincidence and can create a powerful, irrational connection between the two events. The brain struggles deeply with the concept of pure randomness. It actively dislikes chaos and will go to extraordinary lengths to construct a narrative that provides a sense of control. Whether it is looking at the stars and seeing constellations, interpreting market trends based on irrelevant variables, or feeling that a series of unfortunate events is a sign from the universe, your mind is constantly imposing order onto a chaotic reality, forcing you to see patterns that exist only within your own neural circuitry. 5. How your brain learns new skills. Fortunately, this incredible ability to map the world and find patterns is also the exact mechanism that allows us to master new capabilities. The way your brain learns new skills is a testament to its profound adaptability. Every single action you take, from typing on a keyboard to playing an instrument or speaking a new language, requires the coordination of millions of neurons firing in a precise microsecond sequence. When you attempt a skill for the very first time, the neural pathway for that action does not exist. The brain has to manually route signals through a chaotic, inefficient jungle of neurons. This requires immense conscious effort, focused attention, and a massive amount of cognitive energy. You feel clumsy, awkward, and frustrated because the physical highway for that skill hasn't been built yet. The magic happens through a property known as neuroplasticity, the brain's lifelong ability to reorganize itself by forming new neural connections and altering existing ones in response to learning and experience. When you repeat an action over and over again through dedicated practice, the neurons involved in that specific task fire together repeatedly. In the world of neuroscience, there is a fundamental rule: neurons that fire together wire together. With every repetition, the chemical signals between these neurons become stronger, and the physical distance between them effectively narrows. As practice continues, a specialized type of glial cell begins to wrap a fatty substance called myelin around the heavily used neural pathways. Think of myelin as the insulation on an electrical wire. An unmyelinated pathway allows electrical signals to travel at a modest pace. But as the myelin sheath thickens through consistent repetition, the speed of the electrical impulse increases exponentially, allowing information to travel up to 100 times faster. This physical upgrade is why a skill eventually transitions from a grueling, conscious effort into a fluid, automatic habit. When you see an expert musician play a breathtakingly fast solo, they are not consciously thinking about every individual finger movement. Their prefrontal cortex has stepped back, allowing the heavily myelinated, lightning-fast neural highways to execute the complex task effortlessly. In this journey of transformation, mistakes are not signs of failure. They are the absolute biological catalyst for growth. When you make a mistake during practice, your brain experiences a sudden drop in dopamine and notices a sharp discrepancy between what you intended to do and what actually happened. This error signal creates a state of neurological discomfort and heightened attention. It signals to the nervous system that something needs to change, triggering the release of chemicals like acetylcholine and epinephrine, which mark those specific faulty neural pathways for modification. Without errors, the brain does not pay enough attention to change its physical structure. You must fail, feel the frustration, and try again for neuroplasticity to truly engage. Once the hard work of practice is done for the day, the final stage of learning takes place while you are completely unconscious. As mentioned earlier, during sleep, the brain replays the motor patterns and information learned during the day, locking them into place. Studies have shown that if you practice a complex physical task or a new language skill, and then get a full night of high-quality sleep, you will perform significantly better the next day without any additional practice. The brain literally codes the skill into your physical biology while you rest. This incredible capacity for adaptation does not shut down when you reach adulthood. While the brain is tissue plastic during childhood, neuroplasticity continues throughout your entire life. As long as you introduce novelty, maintain consistency, embrace the discomfort of mistakes, and allow for proper rest, your brain will continue to carve out new pathways, reshape its physical structure, and adapt to whatever challenges you throw its way. Conclusion. When you take a step back and look at the totality of these internal processes, you realize that the human brain is one of the most staggeringly complex structures in the known universe. Containing roughly 86 billion neurons, with each single neuron capable of forming thousands of synaptic connections, the total number of pathways inside your skull is greater than the number of stars in the entire Milky Way galaxy. It is an unfathomable biological network operating in absolute darkness, completely isolated from the outside world, receiving nothing but faint electrical impulses from your sensory organs. Yet, from those chaotic electrical signals, it constructs the entire universe you experience every single day. The vibrant colors you see, the profound grief or soaring joy you feel, the memories you cherish, and the fundamental beliefs you hold true are all carefully shaped, edited, and rendered by the brain itself. It does not create a perfect, objective copy of reality. It was never designed to do that. Instead, it has evolved over millions of years to help us survive, learn, adapt, and make practical sense of an incredibly complex, indifferent world. It gives us exactly what we need to navigate life, even if it means altering the past, shifting our identities, or tricking us into seeing things that are not there. The more we discover about the inner workings of the mind, the more we realize how much remains completely unknown. Every insight we gain reveals new mysteries waiting to be solved. It leaves you to wonder, in this very moment, how many more secrets your own mind is still hiding from you.